This video is going to be about piecewise functions, but just about evaluating them, not actually about graphing them. Graphing them will be a separate video. So for an introduction to piecewise functions, as you can see on your screen, a piecewise function is a function that is defined with more than one equation. You can see an example of one there below that as well, meaning you can clearly see that we have two equations here, but that entire thing is one function. Now, if you think about that, then it would initially cause you to, raise an eyebrow or question how this is possible, because we know what the definition of a function is, and the definition of a function is that every input can only be giving us a single output. If we have two equations, and I ask you to, say, find me f of 5, well, that would seem to cause an issue here. Because if we plug 5 into the first equation, we would get one answer, and if we plug 5 into the second equation, we'd get another answer. And so that would cause us to get two outputs for the single input of 5. The catch here is that you will notice we have rules. We have inequalities for each of these equations. You can only plug into one equation for this to still be a function. You have to choose one of the equations. The way we'll do that is by using the inequality rules, meaning the first equation is only allowed to be used if x is less than or equal to 2, whereas the second equation is only allowed to be used if x is greater than 2. If you think about that, you will realize that any x value I could ask you to plug in will only be allowed to be plugged into one of the two equations. For example, with when x equals 5, if we're doing f of 5, well, 5 is not less than or equal to 2. 5 is greater than 2, which means we would want to use the second equation. So if I plug 5 into the second equation, 5 plus 3 would give me 8. And so our answer for f of 5 is 8. That is the only possible answer. Let's say I asked you to find me f of 2, because you may be questioning whether f of 2 would possibly be messing this up. Well, if you look at these inequality rules again, 2 is not less than 2, 2 is not greater than 2, 2 is equal to 2. And there's only one of these inequalities that has the equal to sign with it. So even for 2, where at first it may have appeared that it worked for both equations, we can see now that it only works for the top equation. And so if I plugged that in, there was already a negative in the function. Then I plug in 2 for x and plus 1. Well, those parentheses really aren't necessary because it is just a negative 2. And negative 2 plus 1 would give us negative 1. So f of 2 is equal to negative 1. Recognize these are coordinate points as well, so this would still be useful information if we were going to graph this. Again, that's a separate video, but we have found that the x value of 5 gives us a y value of 8, and the x value of 2 gives us a y value of negative 1. Recognize there is no limit to how many pieces you could have in a piecewise function. You can have as many equations as you can imagine. And no matter how many pieces, no matter how many equations there are, anytime you are asked to plug a number in for x, you will only be able to choose one of the equations to plug into. If you ever plug into more than one, you are breaking the rules of a function.